Hello guys, welcome back to my YouTube channel ECE tutorial. So in the last class I have told you this video will be on the subject BEEE. So the first chapter I have taken here is basics of electricity. So now let us look on to the basic definitions and basic uh, knowledge which you require in these chapters in the further slides. So now let us look on to the basic definition which is very important with the exam point of view. So first is electric current. So electric current is nothing but the continuous flow of electrons in an electric circuit is called as electric current. So in an electric circuit, whichever circuit if you take, how will you know that the electric current is flowing? So when you on the switch, the electric is produced because there is a flow of current. There's a continuous flow of charges, mean the electrons, so which causes the current to produce. So that is nothing but electric current. 1 ampere mean it is defined as the current that flows with the electric charge of 1 coulomb per second. Mean in LA electric circuit there's an electric charge, there's a current flowing when the electric charge is passed. So that current that is produced for 1 coulomb per second. So so here the important thing is that 1 coulomb per second. So 1 coulomb per second, how much electric flow, how much current is flowing, charge is calculated. So that is nothing but the 1 ampere. Next is EMF. So EMF is nothing but electromotive force. It is the electrical action produced by non-electrical sources. Devices provide an EMF by converting other form of energy into electrical energy such as batteries or generators. So any devices if you take like batteries, generators or even motors also. So that isn't just simply an mechanical structure. It just doesn't work or it doesn't produce any current or anything. But when there is an external forces is acting upon that mechanical device, that time it just converts into electrical form of energy through which it starts working. So here we're going to apply electromotive force. So this EMF will produce and it will convert mechanical energy into electrical energy. It can be, for example, weight, a battery, generator, motors, anything. So that in any mechanical structure will get its will be converted into electrical energy by using or by applying electromotive force. So now the next definition we are going to see is electric potential and potential difference. So electrical potential mean it is the amount of work needed to move one unit, a unit of electrical charge from the reference point to specific point in an electrical field without producing any acceleration. So which means here acceleration will be zero. Okay, but the here we are going to calculate the electrical potential by the amount of work. So by using electrical potential we can find out the work you require to move an electrical charge. Here two reference point and the specific point will be taking as A and B. So here a unit of electrical charge will be moving. So to move from this point to this point, how much work you need to do? Work is nothing but Fs, force into speed. So how much work you need to do for moving an electrical charge, a unit electrical charge from A to B is calculated by using electrical potential. Next is potential difference. The difference is in potential between 2 points that represent the work involved or the energy released in the transfer of unit quantity of electricity from one point to another. Here we are going to calculate the difference in potential between 2 points that represent the work involved. So here you can take the same example. So here are the two potentials, right? So between these 2 points, because here you're doing, even the work also is being involved. So between these 2 points, what is the difference? So that difference, that between these two potential points, the difference is calculated by using this potential difference. So here, how much potential is required? So here, A and B, between these 2 points, what is the difference? So what is the difference? It is calculated by using the potential difference. So here, where you're going to calculate potential difference mean where there's a work involved. So there must be some kind of work will be involved, so that this electric potential and potential difference is related to each other in this work. So now let us look on to the important topic, that is law of resistance. So this law of resistance depends upon many factors like environmental condition, or the length, or the cross sectional areas, and many kind of things. But let us look on to the laws of this. There are 4 laws. First law is, the first law states that the conductive material is directly proportional to the length of the material. So here it has been shown R is directly proportional to L, which means R is the resistance of the material and the L is the length of the material. So these both are directly proportional. So according to this law, the resistance of the material increases with increase in length of the material. So as this resistance increases, even the length also increases. As usual, as this resistance of the material decreases, even the length also decreases. That's the statement of the first law. Now coming on to the second law. Second law states that the conducting material is inversely proportional to the cross-sectional area of the material. So that means this uh, conductive material mean the R is inversely proportional to cross-sectional area of the material. So inversely mean 1 by, and cross-sectional area is denoted by A. So R is proportional to 1 by A, which means R is inversely proportional to area, that is the cross sectional area. According to this law, its material increases with the decrease in cross sectional area of the conductor and decreases with increase in cross sectional area. So this is the opposite of first law. So in the first law, as the resistance increases, length also increases, but here as the resistance increases, the cross sectional area decreases, and when resistance decreases, the area increases. So it is opposite of the first law. Then the third law states that the conducting material depends upon the nature of the material. So which means the conducting material mean the resistance depend upon the nature of the material. What kind of material you're going to use, that is depend. So this resistance depends upon what kind of material you're using. So according to this law, the resistance value of the material varies depending upon the type of material. Two wires made up of different materials and having the same length and cross-sectional area will have different values. Mean the resistance value differs according to the what type of material we are using. So when you take two wires, so which is of different materials, then if the even though if the materials mean the two wires length is same and its cross sectional area is also same, say it mean the two wires, because the two wires will be of different materials, even though if it is of same length, its cross sectional area will have different values, right? So the resistance depends upon the what kind of materials you are using. So here they have told that if you are using different materials, even though if it is having same length, but the cross sectional area will have different values. Next, the fourth law states that the conducting material depends upon its temperature. So depending upon the temperature, So the resistance differs upon the temperature. According to this law, when the temperature of metallic conductor is increased, its value also increases. So when the temperature increases, the conducting will be increased. So its values increases. So as this temperature increases, even material the material's value also will be increased. The resistance value will be increased as this. So as this temperature goes up, even the value, the resistance value also increases. So this is the temperature. Here the temperature is increasing, and even the resistance also increases if temperature increases. So that is given by law of resistance is given by R equals rho L by A. R mean resistance, L mean the length of the material, A is the cross-sectional area. So these are the four laws of law of resistance. So next, the specific resistance. Specific resistance mean it is the property of material to oppose the flow of current, electric current passing through it. Specific resistance is defined as the resistance offered by a unit length and unit cross section of a substance to the current when voltage is applied to it. Which means, so it is specific resistance is the property of a material. It is any material. So if you take any wire, it has its own properties. So the same way, the specific resistance is one of the property of a material. So this material opposes the flow of current, this resistance. So in any material, if this specific resistance is present, then it opposes the flow of current passing through it. If electric current is passing through this specific resistance, it opposes the electric current to flow further. That is nothing but specific resistance. It is also defined as the resistance offered by unit length and unit cross section of a substance to a current when voltage is applied to it. So when you apply this voltage, the cross section of the substance, so the unit cross section and the unit length, so these for this, the specific resistance offered mean the resistance, the opposition is applied to this length and cross sectional area when the voltage is applied. So when the voltage is applied, this length and cross sectional area, for this both the resistance will be applied. So this is nothing but the specific resistance. So for this, SI unit is ohm meter. So now let us look on to the Ohm's law, which is very important to the exam point of view. They'll be asking in every question paper. It's a common question actually. So now let us look on to the statement of Ohm's law. Ohm's law states that the voltage across the conductor is directly proportional to the current flowing through it, provided all physical condition and temperature remains constant. So here the Ohm's law states that the voltage will be proportional to the current, V will be proportional to I, right? So if you want to take here I've given R equals VI. So that's if you take it for V, the formula will become like V equals I into R. So here it's nothing but V is proportional to I. It is directly proportional to I. Only restriction is that the temperature should be remained constant. When the temperature is constant, only this Ohm's law will be applicable. So here are some two limitations which I have given. So the first limitation is that it is not applicable for unilateral network and it is not applicable for non-linear element. These are the two technical points which you have to use it. So Unilateral network mean it is when any circuit which in which the current is flowing through one direction. So through that, in that case, this law will not be applicable in even in non-linear elements kinds of network. Also, this Ohm's law will not be applicable. These are some uh, main restrictions, mean the limitations of Ohm's law which I have given. So guys, here you end the basic topics of the Ohm's law, which is very important for further topics also. So in the next slide, I'll be coming with the further topics of this first chapter, that is basics of electricity. So do remember to subscribe and like and share this channel, and meet you in the next video guys. Bye bye.